Welcome back, students. Hello, it's Ms. Hernandez. Thank you for joining us to learn more chemistry. So, good morning, good afternoon, or good evening, whenever it is you're watching. Today's topic is 6.19 periodic trends. We're going to talk today about one trend or different trend, electron affinity. Yesterday, I know, was a very tough subject. There was a lot of information that was covered that we talked about that we hadn't previously talked about. So, there was a lot of new content in yesterday's assignment. But today it's going to be a little bit easier. Okay. So let's get started. So, whenever you're packing to travel or even to go to an aunt's house, taking the days off, you're funny, Mario. Anytime you go to stay over at a friend's or even to go to the beach or even to go see an aunt or an uncle, we always have to pack a suitcase, right? We need to make sure that we have everything we need. Sometimes, especially when I go to the beach, I always overpack because you never know at the beach. It could be cold, you might need a sweater, it might be super hot, or especially, if you're going to stay there for a lot of days, you need different bathing suits, right? So the question for our introduction is, do you tend to overpack going on trips? And that is where we're going to start today's topic, okay? Who's going to read for me? Melissa, are you available? Or is it going to be Oscar or Alexia?
Packing for a trip can be very challenging. What do you take with you? Where will you be going and what will you need? We usually pack too much, like the suitcase above, and then find it hard to close the suitcase. When the suitcase is overfull, there is a stress on the system and forces pushing the suitcase open. When electrons are added to an atom, the increased negative charge puts stress on the electrons already there, causing energy to be released.
All right. So thank you. So if you ever tried to close a suitcase that has too much clothes in it, it's going to be really hard to zip it up, right? Most of the time you zip it up, and then if it's too much, it'll unzip. And then you zip it, and then it'll unzip, right? I don't know if you guys ever had one of those suitcases, but me, I always overpack. So it happens to me all the time. Now, the same thing happens when you overpack an atom, and you can overpack it. You can overpack it by adding electrons to atoms, okay? And anytime you add an electron, energy will be released from that atom, okay? There will be a built up of energy as you're gaining, and it will be eventually released. So when electrons are removed from an atom, energy is required to do anything. When you take away an atom or an electron, you're going to need energy. When you gain an electron, you're going to release energy. So there is always a change in energy anytime you do a reaction. And in this case, we're talking about reactions where you gain electrons as an atom. So here we have our topic. It's electron affinity. And let's start talking about it, right? In most cases, the formation of an anion by the addition of an electron to a neutral atom will release energy. Okay. And you can see it here. Now here you have chlorine plus an electron gives you a negative chlorine and energy. Why? Why? Right? It's always about why. So anytime you have a neutral atom, they're neutral because they have an even number of electrons and protons. And for this chlorine ion, oh, not chloride, ya no estoy cambiando. For chlorine, you are supposed to have 17 protons and 17 electrons. This is why you're neutral. The amount of electrons and protons is exactly the same. So your plus charge, protons, is the same as your negative charge, electrons. Now, what happens when it gains an extra electron? So if you added one electron and you know that you have 18, sorry, not positive, negative electrons, and you have 17 positive protons, look at the charge that you're going to. Stop. Stop it, Daisy. Sorry about that. So anytime you have 18 electrons, 17 protons, you're going to end up with an overall negative charge. And that's what you see here. Bishop. Sorry. That's what you see here. Anytime you have a neutral chlorine and you add an electron, you're going to see that all of a sudden that chlorine has a little negative charge. And all that means is it has gained an extra electron. Okay? And we call that an anion. But of course, we'll talk about more about anions and cations later. The energy change that occurs when a neutral atom gains an electron is called electron affinity. So here is our first our vocabulary word for the day. Energy change. Energy change. That is electron affinity. How much energy is being released? That's what's an electron affinity. As you gain electrons, energy is being released, and they take a measurement of how much energy is being released, and that we call it electron affinity. The easier it is for you to gain an electron, the higher, the more energy you release. Okay, and there are certain groups on the periodic table that will gain electrons easily because, well, I'll explain it in a little bit. When energy is released in a chemical reaction or process, that energy is expressed in a negative number. Okay, so anytime you see a negative number in chemistry, all that means is that energy is going out, energy is being released by that reaction. The figure below shows electron affinities in kilojoules per mole for representative elements. Electron affinities are measured in atoms when they are in the gas state, and it can be very difficult to get an accurate measurement. Okay, so here you have some elements from the periodic table. You have group 1, group 2, 13, 14, all the way to 18. And if you look, these are electron affinities, right? These numbers on the bottom is how much energy is released by that element when it gains an electron. If you look at group 1, electron affinity is low. It gets low, it gets a little bit higher, it gets higher, higher. And look at that affinity for group 17. It's huge. It gives off a lot of energy. Okay? Group 18, they don't usually gain electrons, so they usually have an affinity of about 0. Okay? I'm going to close the door right now. Hold on. Let me push pause. Okay, let's continue. So, there's that group 17, elements of the halogen group 17. They easily gain electrons. And they call it most readily, but I just say easily gain electrons, as can be seen from their large negative electron affinities. So if you look here, group 17 has very large numbers when it comes to electron affinity because they easily gain electrons. This means that more energy is released in the formation of a halide ion than any other element on the periodic table. Considering electron configuration, it is easy to see why. The outer configuration of all halogens is S2P5, NS2NP5. All that means, guys, is that there are 7 valence electrons. 7. Now, the magic number that everybody always wants is 8. We call that octet rule. Everybody wants 8 electrons in that outer orbital, in that outer shell, because that makes that atom stable. And stable means happy. Okay? If you are a happy atom or a happy element, you don't need anybody else. You got your 8 electrons. Okay? The addition of one or more electron gives the halide ions the same electron configuration as noble gases, which we have seen is particularly stable. So let's go back to group 18. This is the noble gases, group 18. And the reason why their electron affinity is about 0 is because those atoms, those elements, they don't need extra electrons. They already have 8. They will not gain more electrons. So their electron affinity is 0, right? Settle. Now, let's talk about the trend, right? There's always a trend on this periodic table, okay? And it, of course, it already erased, so I cannot use what I wrote earlier. So, period and group trends for electron affinities are nearly not as regular as for ionization energy. In general, electron affinity will increase or from left to right, or it becomes more negative. So, as you're going across the periodic table, it's going to increase. And we're not meaning the number is just going to get more negative, okay? It becomes more negative. As you go across this periodic table, the trend is it will increase. Your negative number is going to keep getting bigger and bigger and bigger the more to the right you go. Okay? Now, if you're talking about going down a group from the top to the bottom, it's going to decrease. Okay? And what does that mean? It will become less negative. It will become less negative. As you go down this group, these numbers will get smaller and smaller and smaller. Any questions? However, there are many exceptions, right? Every trend on the periodic table is going to have exceptions, okay? And some, as far as measuring the electron affinity, some of that information is not 100% accurate because it is difficult to measure electron affinity. All right, we're done with lecture. Let's watch this video. We'll talk about the summary and then we are done and I'll give you some time.
Electron affinity. Electron affinity is the amount of energy that is released when an electron is added to an atom. What this means is that a positive electron affinity value represents the energy release when an electron is added because of the attractive pull of the nucleus on the electrons. So the greater the electron negativity will be if there's more attractive force by the nucleus. What electron affinity tells us really is how an atom feels about gaining another electron. If it has a small electronegativity, it does not want another electron. Because affinity means a liking to or want for something. And it doesn't really want that. A large electron affinity means it does want an electron, and so it's looking for more electrons. So that corresponds to a periodic trend. The periodic trend for electron affinity is that electron affinity increases when we move from left to right. So when we move from left to right across a period. And electron affinity decreases when we go from top to bottom. So when we go from top to bottom in a group. And there's a decrease there because remember the attractive force of of an atom increases from left to right, of the atoms increase from left to right, because the nucleus is getting stronger because it has more protons. So if we look at this in a periodic table from left to right, we're moving in this direction, electron affinity increases. And as we go from top to bottom, it decreases. However, we have to remember that this last row, they're pretty happy with having 8 valence electrons, or 2 for helium, because it's filled up its valence shell, or its highest energy shell. So it's filled those up. So any He, Ne, Ar, Kr, the noble gases aren't really looking to have an electron affinity. So they have close to 0 electron affinity. So that means they would have the lowest, no matter that they are, even if you say when we're increasing from left to right, that the affinity increases. But because here, when we arrive to noble gases, they're full. They've achieved the octet rule. They have little to no electron affinity because they're already happy with what they have. So remember that these noble gases have no electron affinity, but here the pattern or trend still holds.
All right, so that's the same thing that we're talking about, in case you needed to hear it in a different way. All right, so let's summarize today's topic. Electron affinity is a measure of the energy released when an extra electron is added. Okay, so anytime an atom gains an electron, right? Anytime it gains that electron, there's going to be an amount of energy that is going to be released from that reaction. Electron affinities are measured for elements in the gas state. In general, let's talk about trends. As you go across the period, left to right, your electron affinity will increase, meaning it's going to get more and more negative. As you go down from the top down a group, electron affinity will decrease. It's going to go down. It's going to become less negative. Okay, less negative. That negative number is going to get smaller and smaller and smaller the further down you get in a group. Okay, so you got 5 review questions to do. If you are working on your own, for those of you who are asynchronous, make sure that you skip number 5. It is hard. I'm going to have to help my students with it right now. All right, thank you for tuning in, guys.